Hey everyone, welcome to this explainer. We literally live in a world that is just absolutely drowning in numbers, metrics, and figures. But let's be real, raw data, it's just a chaotic mess until we actually interrogate it properly. So let's uncover the true story hidden inside all of that noise by mastering the statistical foundations of centrality and dispersion.
So, how do we find the truth hidden inside messy data? Think about it for a second. When you're staring at a massive, sprawling dataset, you're really just searching for the signal within all that noise, right? I mean, how do we take thousands of scattered data points and boil them down into a cohesive story that actually makes sense? Well, statistical analysis is basically our magnifying glass to solve that mystery.
Okay, let's dive into this. Here is our roadmap for today. 1. Summarizing the data. 2. Choosing the right center. 3. Pearson's skewed relationship. 4. Measuring the spread. And finally, 5. Comparing different data sets.
All right, section 1, summarizing the data. Let's start solving this data mystery by looking for our anchor.
Our very first step in making sense of any dataset is establishing an anchor point. Now, you probably already know the mean. It's just the simple arithmetic average. It's our absolute most common tool, and we use it to find our footing by identifying the mathematical center of gravity for all of our numbers. Next up is the median. When you line your data up sequentially, boom, this is the absolute middle ground. And it's an incredibly powerful anchor because, unlike the mean, it totally ignores those extreme outliers pulling at the edges.
And finally, we have the mode. Simply put, it's just the most frequent or most popular value that pops up in your data. Between the mean, the median, and the mode, we've got a complete 3-part toolkit for defining our central tendency.
Moving on to section 2, choosing the right center. Now, you might be wondering, how do we actually know which of those 3 tools to use?
Well, we can't just pick our favorite one, and this brilliantly illustrates exactly why. Every single measure of center has its proper place, and that's dictated entirely by the type of data we're looking at. If your data is nominal, you're going to lean on the mode. For ordinal, ranked data, the median is your best bet. Symmetrical data, that pairs perfectly with the mean. But a quick warning here, if your data is skewed, the mean will completely deceive you, making the median your safest bet for sure. Which brings us to section 3, Pearson's skewed relationship. Let's look at a really fascinating connection that happens when our data isn't perfectly symmetrical. So what exactly happens when data gets lopsided? Well, enter Carl Pearson. He discovered that even when visual symmetry totally breaks down, these 3 anchors don't just scatter randomly. Actually, they follow a rigid, predictable mathematical rule. Specifically, he found that the distance between the mean and the mode is exactly 3 times the distance between the mean and the median. It's like this beautiful hidden structure, even right in the middle of chaos. Now for section 4, measuring the spread. I have to warn you, finding the center alone is a pretty dangerous trap. So the crucial point is that relying purely on the center gives us a totally incomplete picture. Imagine 2 different cities, both with a 60-degree average temperature. But City A is a pleasant 60 degrees year-round, while City B swings violently between freezing blizzards and scorching heat waves. They have identical centrality, but completely different realities. To understand the true shape of the data, we absolutely must measure the dispersion.
And here is our arsenal for measuring that spread. We've got the range for those absolute extremes, quartile deviation for the middle 50%, mean deviation, and of course, the heavyweight champion, standard deviation. That one actually factors in every single data point's square distance from the center. Together, these 4 tools tell us exactly how far our data travels from that center anchor we found earlier. All right, last but not least, section 5, comparing different data sets. So what does this all mean for us when we're out in the real world? Now, what's really interesting about this slide is how we use this knowledge to compare 2 completely different sets of data. We use what are called coefficients of variation. Think about it. You can't really compare the spread of apple weights in ounces to car prices in dollars, right? But by dividing the standard deviation by the mean, we create a standardized relative percentage. This acts as the final polish, allowing us to safely and accurately compare the volatility of datasets that seem entirely unrelated. Identifying the center gives us a fantastic starting point, but dispersion, that gives us the undeniable truth. So I'm going to leave you with this. The next time a flashy headline tries to sell you a story based entirely on an average,
Will you stop and ask for the spread? Keep asking questions and never, ever settle for an incomplete picture.